Hi, in this video, we're going to talk about how we can factor polynomials completely into their linear factors. In previous videos, we learned how to use synthetic division. And to do synthetic division, it has to have a purpose. What is the purpose of synthetic division? This is what we're going to talk about together today. But we're going to start with number 5. And number 5, we're still working in section 4, 2.4, and this is page 205, and this is the quick review section. And number 5 says factor the polynomial into its linear factors. So if we take number 5, it's a cubic polynomial. The first thing I should think about when I want to factor is there a common factor? And if I look at both terms, yes, there is, which is x. We take x, we open parentheses, then we divide each term by x. X cubed divided by x is x squared. And 4x divided by x is 4, with the negative, of course. And I will look at this expression and I'll look at the question and I'll see if I answered the question. And I did not yet because it says linear factors, and this is not linear, this is quadratic, which means I did not finish factoring yet, and I need to keep going until all the factors are linear. So if we look at this should look very familiar. It's a special case, which is a squared minus b squared, the difference of squares. And the way we factor this, it's a minus b into a plus b. So if I factor this, I should get x minus 2 into x plus 2. And of course, I should keep the common factor that I figured out before on the front of this. So this is a common factor. Now we are done because every single factor is linear. So we factored the cubic into 3 linear factors. And then we can find the x-intercepts, we can analyze the graph, and we can do lots of things after we factor. If we take a look at number 9 is going to be a little bit different because number 9 has a cube or is a cubic polynomial. If we look at the terms, we cannot find the common factor for all the terms. If you say x, but x is not common to 2, so there is a constant right here. So right there, to factor this cubic polynomial, there's multiple ways. We're going to talk about 2 of them. There's actually 3 or more ways to factor this polynomial. The easiest way would be just to graph it. So if you graph the cubic polynomial in number 9, you're going to get this graph right here that I graphed on decimals. And I can see all the x-intercepts. And after you graph it, you're going to look at the x-intercepts. And from the x-intercepts, you're going to write down the factors. So I see -2, -1, and 1, which means the factors are x plus 2, x plus 1, and x minus 1. The reason why this graphing works nicely here and easily because a equals 1 in this case, which makes things so much simpler. Now, this is not an algebra way to factor. This is a graphing way. That's only if we have a graphing calculator we could do this. Another option to do that is something called rational zero theorem. We didn't get into details, and we are not going to get into too much details with this, but I could give you a quick overview, which will be helpful if you didn't have a graphing calculator. You look at the constant and you list the factors of the constant. So what multiplies to 2 is 1 and 2. Those are the factors of the constant. Plus or minus, we take all options because you could make a -2 out of 1 and -2 or out of -1 and 2. So there's different combinations. So what you could do is apply the factor theorem and see which one works. So let's say I plug in 1 in the function. If I get a 0, and I will if you try it, I'm gonna get x minus 1 as one of the factors. If I plug in -1, you can try it and take your time with it, but you are gonna get a 0, and which means x plus 1 is another factor. If I plug in 2, I am not going to get a 0, which means x minus 2 is not a factor. And if I plug in -2, I am gonna get a 0, which makes x plus 2 a factor, and I got all the linear factors using this. Another option would be, once you get one of the zeros, one of the factors, you could do synthetic division, and that's what we're gonna do in number 25 in a second. So again, just to recap, when you have a cubic that doesn't have common factor, it makes things harder. If you have a graphing calculator, perfect, that's all what you need. You graph it and you look at the x-intercepts and you make the factors out of the x-intercepts. If you don't have a graphing calculator, you can simply look at the constant, take the factors of the constant, plug them in. The one that gives you 0 are the ones that would give you a factor according to the factor theorem. Now let's take a look at 25. 25 is a little bit different, but it says, use the graph to guess possible linear factors of f of x, then completely factor with the aid of synthetic division. And even if they didn't tell us with the aid of synthetic division, we should know that after we guess some factors, we can use synthetic division. So I'm going to take a look at the graph, and we know what are the important points. The x-intercepts, those are exact ones. This is -3. This is 1, which makes x plus 3 a factor, and this makes x minus 1 a factor. And this is not exact, so we need to estimate it, and we're not going to do that. We are going to get the exact one. So what we're going to do, because they said with the aid of synthetic division, we figured out 2 factors. We need the third. This is what's missing. We're going to use synthetic division. And what are we going to use? What are we going to divide by? We can either use -3 or 1, because those two are the zeros of the divisors. So I can use -3 or 1. I'm going to choose to use a 1 just because it's more friendly. And I'm going to put all the coefficients, just as we explained in a different lesson, the synthetic division, 5, -7, -49, and +51. Gonna drag the 5, multiply, add, then multiply again, then add, then multiply and add, which proves that x minus 1 was a factor, and we were definitely sure. We weren't even questioning because we can see it from the graph. So is a factor. Now, this makes it, if you guys remember, we said it will be helpful to put on top of each one what was next to it. And this is the constant. So, which makes this a 5x squared minus 2x minus 51. And to write it in polynomial form, which is the divisor multiplied by the quotient and plus the remainder, and there's no remainder right here. I'm just going to fix this to a -51. Again, there's no remainder, which explains why 1 is the 0 of the divisor. We are not done yet because this is not linear. So we need to break this down more. If you want to do X method, you can go ahead and do X method. But another option, friendly option, would be to do the synthetic division again. And now I'm not going to use 1, but I'm going to use -3 because I already used 1. And I'm going to take this quadratic, 5, -2, -51. This had an x squared next to it. This had an x, and this is the constant. I'm going to do the synthetic division. So I'm going to drop down the 5, multiply, add, multiply, add, and I wasn't surprised to get a 0 because I know I had that -3 is the 0 of one of the factors, which in other words means it's the x-intercept. This was x squared, drop it down to x. This was x, and which will become the constant. Now, let's rewrite this in factored form. So f of x will have 3 factors. The x plus 3, the x minus 1, and both of these we were able to get them from the graph by doing double synthetic division or doing synthetic division twice. We got the third factor. So f of x in factored form will be x plus 3 into x minus 1 into 5x minus 17. And if you want to find the x-intercepts from the factored form, this is going to give us -3. This is going to give us 1. And this one right here is going to give us a 17 over 5. If you solve it, 17 over 5 is a 3 point something. It's a decimal that is a little bit over 3, and that's what explains the estimation here. If we would have estimated, to like 3.2, for example, but we said we don't want to estimate and we want to give the exact value, and this is what we were able to do by using the synthetic division twice, and we got 17 over 5. And if you do on the calculator the approximation of 17 over 5, it's 3.4, but we don't even need to do